Hey guys! Today we're going to take a look at reviewing how to write ionic formulas and ionic names. So the first thing we have to do is take a look at oxidation numbers. Remember, an oxidation number is the charge that the element wants to have once it has a complete or a completely empty outside shell. So for example, sodium. Sodium has a single valence electron, and in class we broke down the protons, neutrons, and electrons to explain how this works. Sodium wants to get rid of that one valence electron to have a completely empty outside shell, which will drop us down to the full shell of the level 2s. We have all 8 of those electrons on the second level. So we have 11 protons, and we currently have 11 electrons. Once this guy gets kicked out and leaves, we have 11 protons and 10 electrons. That leaves us with an overall +1 charge, so our oxidation number is +1. Oxygen works similarly. He has 6 valence electrons, and if we write down all the same information, he has 8 protons, approximately 8 neutrons, and currently he has 8 electrons. He has the option of either gaining 2, putting an electron here and here, or losing those 6 from that outside shell. Oxygen is actually going to gain 2, so he still has 8 protons, but now he ends up having 10 electrons. This leaves us with an overall -2 charge. Now I do all this work to explain it to you, but you don't actually have to do this every time. The next slide has the information about how we recognize the pattern on the periodic table. So here's our pattern. Everything in the first column underneath hydrogen has an oxidation number of +1 because they have one valence electron that they really want to get rid of. This column has an oxidation number of +2 because they have 2 valence electrons. The transition metals vary. They can have oxidation numbers anywhere from 1 to 4, and it just depends upon the individual element at the time. I will tell you this information either by giving it to you through their name or by looking at their chemical formulas and using their formulas to determine it. Everything underneath boron has 3 valence, so it's +3. Everything underneath carbon can go either one way or the other, and they have a charge of either +4 or -4, -3, -2, -1, and then the last column does not bond, so its oxidation number is 0 because it does not want to have a charge. So we talked about this in class, and we saw the pattern, and we worked our way through. Now the steps for writing the formula. Remember, in class I explained that this is a lot of words and a lot of explanation for something that is relatively simple. You write the chemical formula of the element with its positive oxidation number as a superscript. If it is a transition metal, the number in parentheses is the oxidation number. It is given to you. Write the symbol of the element that has the negative oxidation number with the oxidation number as a superscript. Then circle criss, circle cross, crisscross the numbers down. Remove the charges and simplify the numbers if possible. So for sodium, Na has an oxidation number of +1. Oxygen has an oxidation number of -2. That's our first step and our second step. Third step, circle criss, circle cross. And our fourth step, remove the charges and simplify. Na is our first element, and this 2 has dropped down to be with Na. O is our second element, the 1 dropped down to be with the O, so we do not have to write it. Na2O is our chemical formula for sodium and oxygen. Here are a couple other examples. Aluminum and sulfur. Aluminum is Al with a +3 oxidation number. Sulfur is S with a -2 oxidation number. Circle criss, circle cross, and then rewrite with the numbers as subscripts with no charge. So Al is written with the 2, S is written with the 3. Manganese 3 fluoride is our transition metal example. Manganese is Mn. It is in the transition metal section, or the D section of the periodic table of the elements. This number, the 3, tells us that Mn has an oxidation number of +3. Fluorine has an oxidation number of -1. Circle Chris, circle cross, and then rewrite Mn. You can place a 1 down here. I do not require it. F3. And that is our final for manganese 3 fluoride. Now, when we name the transition metals, everything else is relatively easy. You've done this back from drawing the bonds to writing the formulas to naming. The first word stays the same, the second word gets the ending of IDE. The transition metals make things a little bit tricky. You have to check your nonmetal. If the nonmetal's oxidation number is not correct, you do need to adjust. And then add the oxidation number of the metal in parentheses. So on the next slide, I'm going to explain our way through this. Ti3N is our first example. What we have to do is take our subscripts and reverse crisscross them back to the top. Even though there is not a number here, we still know there's at least a 1. So we are left with Ti plus 1, N minus 3. Ti is the metal titanium, so I'm going to write the word titanium. Nitrogen, we change the ending to nitride. And since this is a transition metal, we do have to have a number in parentheses. So we look here to our nonmetal. Nitrogen's oxidation number is supposed to be -3, so titanium's oxidation number is correct, and in that parentheses we are going to write a 1. So since nitrogen did not have to be adjusted, titanium was fine. Now we have manganese O, manganese oxide. I'm going to write down manganese, parentheses, oxide, and we take our down low numbers and send them back up to the top. And remember, even though there aren't any numbers there still has to be at least a 1. So we have Mn plus 1, O minus 1. Now oxygen's oxidation number is supposed to be -2. So when we combined these into our compound, we ended up simplifying our subscripts. Since this one is supposed to be -2, we divided both of them by 2 to simplify them out. That means here we have to multiply by 2. Manganese plus 2, oxygen minus 1. Since this one is now correct and it matches the periodic table, I'm going to write a 2 here. This last example we are not going to do because I wrote it incorrectly, so we're just going to ignore it. Okay, so that is our review on how to write the chemical formulas and how to write the chemical names. The chemical names are going to be the trickiest part, so check back here when you need a refresher. Remember, our steps. Reverse crisscross your subscripts to determine the oxidation numbers. Check your nonmetal. Is it correct? If not, adjust it. You will be multiplying by a number to adjust it back to what it should be. The name of the cation or cation stays the same. Write the oxidation number that you just determined through step 1 in parentheses. The name of the anion receives the suffix of IDE, and then you're done.